Hello guys, this is Mr. Election, SS1 mathematics class. It's good to be back here again. So last time we continued about construction. I've been doing for the previous 2 weeks how to construct type from construction of album 1960, and we talked about bisection. Remember I told you bisection is how you can split a line segment into two, and you can also use to split an angle into two. So basically, bisection is what like dividing, so I call it splitting or dividing. So we started from construction of angle 90, and we bisected angle 90 to 45. We constructed angle 60 and bisected to what? Angle 30. So the last class we proceed to construction of a quadrilateral polygon, and I told you a quadrilateral polygon has four sides. So in construction of a quadrilateral polygon, it depends on the properties or the details of the construction given, because a quadrilateral polygon will either be what? A square, whereby a square has all the sides what? Equal, and all the internal angles are what? Equal. A quadrilateral polygon has four sides, and all the internal angles are what? Equals to 360. So in square, all the angles are about 90, 90, 90. So we are given to construct what? Angle 90 of four sides, you know that's a square. Whereas it's different from what? A rectangle, a rhombus, a kite, a trapezium. All these has what? Four sides. They all have what? Four sides. So in construction of a quadrilateral polygon, it depends on the what? On the sides or the details of the what? Construction given. So we also went talked about equilateral triangle. From the types of triangle, we know equilateral triangle is a triangle that whereby all the sides are what are equal. They have what? Equal size, and the internal angles are what are equal. And we all know the sum of angles in the triangle is equal to what? 180. And in the case of equilateral triangle, all the internal angles must be what? 60, 60, 60. So in construction of a equilateral triangle, we talked about that also, and I gave you what? The steps to follow. So we went to what? Locus, the points. We talked about two types of locus, whereby locating a point from another what? Fixed point, and what? A point which is equidistant what? From two other what? Other points. So that's what we discussed in the last class. So this week we'll be looking at some deductive proofs. We're talking about deductive proofs, but we're looking at how to prove the sum of angles in a triangle. We talked about properties of a parallelogram. We talked about what? Congruent triangle, intercept theorem, and all that. But first, I would like to share with you the learning objective of the topic. The learning objective. So, week 5 mathematics, deductive proof. So this is the learning objective. At the end of the lesson, students should be able to calculate the sum of angles in a triangle. We all know the sum of angles in a triangle is what? 180. So I'll just show you how to go through that. Explain the relationship of triangles on a straight line. So when triangles are what? Attached to a straight line, so what are we going to consider in this case? So we'll look at those things and calculate angle on a parallel line cut by a transversal line. We all know what a parallel line means. A parallel line are lines which do not meet, regardless of their length. Be it a continuous length or a given length, they will never meet. They will never meet. Calculate congruent triangles. We all know what if you don't know what congruent triangles they are like, they are different from similar triangles. When we say congruent triangles, that all the dimensions are the same. They have the same shape. They are both triangles, and their dimensions of each triangles are the same. That's what we call a congruent triangle. So let us move to the first one. The first slide, we'll go to the sum of angles in the triangle. The sum of angles in the triangle. The sum of angles in the triangle is what? 180, and it was a triangle has how many sides? 3 sides, and it has what? 3 angles. The triangle is made up of 3 sides and 3 angles. Give it, and the angles in the triangle is what? ABC. Considering that the 3 sides of these 3 angles in the triangle are what? ABC. So the sum of angles in the triangle now, but what's the addition, the sum of all the individual angles in the triangle to give you what? 180. Everything must be equal to what? 180. That is A plus B plus C must be equal to what? 180 degrees. A plus B plus C must be equal to what? 180 degrees. So let me show you a diagram about it. So this is a triangle. Sum of angles in a triangle like this: angle A, angle B, angle C. These are the 3 angles that makes up what? A triangle. That is angle A plus angle B plus angle C must be equal to what? 180. That is to make up that, or to follow the theorem that the sum of angles in a triangle is equal to what? 180. Angle A plus angle B plus angle C must be equal to what? 180. I said provided you are given what? Angle A and angle B, and angle C is missing. There's no worry about, you don't have to worry about that. All you just need to do is what? Sum angle A plus angle B plus the missing C equated to what? 180. Then you get what? See the subject of the formula. then you get what the value of what the side or angle of what C. And let's say write it at A is 70 degrees or and B is 60 degrees. That is 70 plus 60 plus C equals to what 180. 70 plus 60 will give you what 130. You minus that for what 180, which will give you what 60, making what angle C equals to what 50. Then if you add angle C 50 plus angle B 60 plus angle A 70 to give you what 180 degrees. Consider this example. Let's consider this example. The angles of a triangle, the angles which must be equal to what 3 angles of a triangle are x, 2x, and 3x. As the angle one side A equals to x, B equals to 2x, and C equals to what 3x. Find the value of what x in degrees. Find the value of what x in degree. This is one of the simplest what question you can get in the angles of a triangle. And finding the sum of angles is one of the simplest questions you can get. That is what you need to do is what sum the 3 angles together and equate it to what 180 to follow the theorem, which is sum of angles in a triangle equals to what 180. That is x plus 2x plus 3x equals to 180 degree. X plus 2x plus 3x equals to 180 degree. That is x plus 2x plus 3x will give you what 6x equals to what 180. Make x the subject of the formula. That is divide all through by what 6. 6x divided by 6 and 180 divided by 6 will give you what x to be equals to what 30 what degrees. And the angles are what x, 2x, and 3x. X, 2x, and 3x. When x is what 30 degrees, 2x will be what 2 times 30 degrees will be what 60 degrees. When 3x equals to what 3 times what 30 degrees to give what 90. To what to affirm our theorem, which is what sum of angles in a triangle equals to what 180. Then we say 30 plus 60 plus 90, which will give you what 180 degrees. That is x plus 2x plus 3x equals to what 180 degrees. So that is about sum of angles in a what in a triangle. So move to the next thing. Relationship of triangles on a straight line. Relationship of what triangles on a straight line. Look at it here. This is a triangle. Consider this triangle A, B, C, and this is a straight line labeled what x. Straight line is labeled what x. On a straight line, these angles are all these 3 angles are made of what on the straight line. Like just like the sum of angles in the triangle is what 180. Also, the sum of angles on a straight line equals to what 180 also. The sum of angles on a straight line equals to what 180. It might not be 3, it might be 2, but the sum of angles made on a straight line equals to what 180. That is that red color angle and the yellow color and the blue color here equals to what 180 on a straight line. Sum of angles are what on a straight. So we're looking at the relationship of triangles on a straight line. This is a triangle connected to a straight line at the edge of what A here. So these are the angles in the triangle is what yellow, blue, A, B, C. These are the angles made in the triangle. When we are relating a triangle to a straight line, there will be what extended angles made with what the straight line. There's an angle formed from this angle here of the triangle with this line. You can see this is angle from the triangle extended to this line, giving what another angle, and this is another angle from this edge to the what to the line here, giving what another what angle, angle. So this is the yellow angle here, the blue angle here, the red angle here makes the triangle. Why the extended angle? Those ones are makes the what interior what angle, the internal what angles inside the triangle. But the ones extended made with the straight line gives what the exterior angle. So we have two types of angles in this case. We have the interior angles and the what exterior angles. The interior angles are this angle 1, 2, 3 inside of the what triangle. While those ones made are connected to the line here are called the what the exterior angle, which is this. And this you can say this angle, this exterior angle has the same color as it. That is showing that they are the same. We call them what alternate angles. Likewise, this also making with this exterior angles, this exterior angle and this exterior angle are the same. They are also what exterior angles. So when we are talking about the relationship of triangles on a straight line, we are looking at the extended what angles made with that straight line, which gives what the exterior angles and the what interior angles. We all know from our previous slides that the sum of angles in the triangle is equals to what 180. Sum of angles in the triangle equals to what 180. So consider this. Let us take the note on it. The interior angles of a triangle is any angle which is formed within the triangle itself. Like I said earlier, these are the what interior angle. They are made inside of the what the triangle. They are called the what interior angle. While the exterior angle of a triangle is formed outside the what the triangle. These are the exterior angles. Just these two, this red and the blue are the exterior angle. The yellow is what is an interior what angle. So such a stereo angle will be formed when one or more sides of such a triangle are what are produced. So the angle extended from A produces what? An exterior angle what? With a straight line. Excuse me. Note, the exterior angle of a triangle is equal to the sum of what? Two opposite interior angles. The exterior angle of a triangle is equal to the sum of two opposite interior angles. For example, look at this angle here. Let's say this is 60 and this is 40. This is what? 60, this is 40. Obviously, you know that this angle here is what? 60 plus 40 minus what? 180, which will give you what? 80. Sum of angles in a what? In a triangle. So you have to consider all these information very, very well. Know your exterior angles and know your interior angles. And with this, you can solve through any question. Provided you're asked to find this this angle here, this exterior angle here. If you can find this angle, obviously you know that this angle equals to what? This angle here. They are what? Alternate angles. We'll talk more about it when we are looking at a transversal line that cuts a parallel line. I'll explain that you have to alternate angles better, but you can get the information from here also. And this angle here is equal to what? This angle. So we asked to find this angle, provided you have you are given this angle and you are given what? This angle. You can also find this angle, provided it makes what? The sum what will give you what? This angle, that is everything will give you what? 180. The sum of all the interior angles must be equal to what? 180. So if you can find this missing angle, also you have gotten what? The mixing what? Exterior angles, which are alternates to what? To one another. Which are alternates to what? One another. So that's the relationship between what? Of the triangles on a straight line. So let's look at the next slide. Angles on parallel line cut by a transversal line. First, you should know what the parallel line is. The parallel lines are lines which do not meet, regardless of their length or a given length. They do not what meet. It could be continuous line, but they will never what? They will never meet. Cut by what? Transversal line. Two or more lines are said to be parallel if when drawn on the same plane. Two or more lines are said to be parallel if when drawn on the same plane, they will never meet whatever length of what production. This line are called what? Parallel line. Regardless of their length of what production, they will never meet. So sometimes two or more parallel lines may have one or more lines drawn across them. Such lines are called the what? The transversal line. Look at this now. This is it. This is a what? This line here is a what? Parallel lines. They will never meet. Look at their direction, the way they are proceeding. They will never what? They will never meet. What? This line drawn across them is called the what? The transversal line. So they have drawn across the what? The line drawn across the what? Two or more parallel line is called the what? The transversal line. And angles are formed at the point of intersection between the parallel and the transversal line. Angles are formed between the what? At the point of intersection. You know what point of intersection means? The point where two lines meet. So this is the transversal line, and this is a one. This is the first parallel line. They meet at this point. So angles are what formed. This angle here, there's an angle here, there's another angle here, there's another angle here, and there's another angle here. So here also the second parallel line with the transversal line, there's another angle here, angle here, angle here, and angle here. So at the point of intersection between the transversal line and the parallel line, there is a what? An angle is what? Is formed. So this gives you this angle gives you a circle here. If you calculate all the angles made here, you have what? 360. And if you and I told you earlier that angles on the straight line, if you calculate any angle made on this straight line here, to give you what? 180. So every angle made at this point of intersection will give you what? 360. So let us look at these angles formed at this point of intersection. We have two types of angle. We consider the corresponding angle and the alternate what? Angles. We also have a vertically opposite angle, but in this topic we will be restricted to what? Corresponding angles and alternate angles. So let us look at the corresponding angles. On each but similar position of the transversal angles, you all know what the transversal line is. The line that cuts two or more parallel lines is called the what? Transversal line. On each but similar position of the transversal angles with intersection on the parallel lines and the what? Transversal itself. Look at this now. We use the color to indicate what? The corresponding angles here to show that this one is what? Correspond to what? This one. That's it. Look at the explanation very well. On each line, but similar position, the angles formed there. On each line, but similar what? Position. Look at this. This is a parallel line AB, another parallel line CD. Transversal line E, label E here. At this point here, one is on the same position as the point of intersection on the what? Second what? Parallel line. So 1 and 5 are what corresponding what angles, because they are on the what same position on the what of the what angles formed at the point of what intersection. 1 and 5, you can see their position here. It is made at this point, and this is also made at what at the top level here. At the top level of this what line with this with the transversal line, the angle formed between this position of the parallel line and the transversal line 5, and that of what A and what E here, 1 and 5 are what corresponding what angle. Likewise, here 2 on the first parallel line and 6 on the second parallel line are on the same what position. So they are called what corresponding what angles. Likewise, that of what 3 and 4, you can say this 3 what with 7 and 4 what with what 8. So these are called what corresponding what angles. If one is 30 degrees here, obviously for 5 years is what 30 what degrees. If you are given or you are not given, you should know that what they are corresponding angles. If 4 is what 20 here, obviously what 8 is also what 20. If 4 is 20 here, 8 is also what 20, to indicate that what they are corresponding what angles on each line, but similar position on the of the transversal angles with intersection on the parallel line are the transversal what itself. So these corresponding angles are the angles formed on each but similar what position on each. The angles formed on this line but similar position with this one, we call them what corresponding angles. So we look at the alternate what angles. Alternate what angles. This one is different from the what corresponding angles. So when two angles are formed on opposite side, when two angles are formed what on opposite side of the transversal within the two parallel, such angles are said to be alternate. When two angles are formed on the opposite side, one and this is let's say this is a opposite side of this, and this is an opposite side of this. This is the bottom, and this is the top. This is an angle formed at the top of this what transversal with the parallel line, and this angle is formed at the bottom with the what transversal and the what parallel line. So look at this angle. They are what opposite to what one another. These are called what alternate what angle. They are formed on the what opposite side of the parallel and the transversal line. So this angle here, look at the angle. If you are label this one A, if you are label this one A, this one is what same as what A. They are called what alternate angles. Unlike the corresponding angles, if you are looking for corresponding angle, this angle will be equal to what this angle here. This angle will be equal to what this angle here. But alternate angles, it's what they have what opposite what they are alternate to one another. Let's say they are what alternate to one another. So this angle here label A is equal to what this angle here label what A. So these are the two types of what angles formed when a transversal line cuts through what two parallel lines. So looking at what we've been talking about earlier, the sum of angles in the triangle, the interior and exterior angles, and we talked about corresponding and what alternate angles. I believe you understand those explanations very, very well. So we'll go to the next thing. Let's move to the next thing. Congruent triangles. Congruent triangles. Congruent triangles. Two triangles are said to be congruent if they have exactly the same dimension. In your junior classes, we discussed about similar triangles. Similar what triangles? In similar triangles, they are equal by what shapes? They have the same. If you are saying similar triangles, from the basic English, they are what equal. They have the same shape. They have the what same shape. But when you call a triangle, two triangles congruent, that is their dimensions are what the same. That is their sides must be equal, and their interior angles must also be what be equal. Look at this triangle. Consider this triangle ABC. Triangle what ABC. A triangle has three sides and what also has what three angles. Made up of what three angles. Look at the three sides. AB is equals to what ED. AC is equals to what DF, and BC is equals to what EF, showing that all the dimensions are what the same. So this is what we call what a congruent triangle. Two triangles are said to be congruent if they have exactly the same dimension. That is, one, the same shape, and what the size. The same shape and what all the size. That is, the size of AC is equals to the size of what DF. The size of AB is equals to the size of DE. The size of CB is equals to the size of what EF. And consider the angle A. Angle A is equals to angle D. Angle B is equals to angle E. And angle C is equals to what? Angle what? F. They have the same what? dimension. For triangles to be congruent, any of the following conditions must be present. So, for you to now consider or conclude that a triangle is what? Congruent, we have 4 basic conditions to be considered. We have 4 conditions to consider before you now finally conclude that, okay, these triangles are what? Are congruent. That is, they have what? The same dimension. So let's go to the conditions to consider. We call it conditions for congruent triangles. Conditions for what? Congruent triangle. For 2 triangles to be congruent, number 1, 3 sides of one are respectively equal to the 3 sides of the other. That is, first thing you consider, we call them SSS. That is, all the 3 sides of one triangle must be equal to all the 3 sides of what? The other what? Triangle you're considering. The 2 triangles must have equal size. That is, if one side is 5 here, another side is 4 here, another side is 3. On the next triangle, on the other triangle also, one side must be 5, the other, another side must be 4, another side must be what? 3. That's why we said 3 sides of one are respectively equal to the 3 sides of what? The other. That is for a first consideration, when you see a triangle, 2 triangles, whereby all the sides are what? Equal, you say they are what? Congruent. Number 2, 2 sides of one and the angle formed between 2 sides are equal to 2 sides, and the angle contained and the 2 sides of the what? Or we call this one SSA. That is, you can say triangles are what? Congruent if 2 sides are equal and one of the angles are also what? Equal. 2 sides are what? Equal and one angle what? Is equal. A triangle is made of what? 3 sides and 3 angles. If 2 sides of those triangle has the same what? Dimension of the 2 triangles, they have the same dimension, and one of the angles may form also is equal to the what? One of the angle formed the what? In the other triangle, can say they are what? Also congruent. That is, 2 sides and one angle must be what? Congruent. The third one says 2 angles and the side of a triangle are equal to 2 angles and corresponding side of the other triangle. That is AAS. 2 angles and one side. That is, 2 angles of a triangle and one side must have the same dimension what? In the what? Other triangle. That is, 2 angles here and one side must be equal to what? 2 angles and one side in the other what? Triangle. First is, in a right angle triangle, we consider this in a right angle triangle. If the hypotenuse and one side in your triangle are equal to the hypotenuse on the other side of what? Another triangle. That is, if you have a right angle triangle, the hypotenuse and one side must be what? Equal to the what? Other what? Triangle. That is, the hypotenuse of this triangle must be equal to this hypotenuse of this triangle, and one other side must be equal to the what? The other side of that what? Triangle. So look at the diagram explanation of it. So this is XSS. This side, all the sides must be what? Equal. 3 sides must be equal to the what? Other what? Triangle. That is, this shows that they are equivalent, they are equal. This side is equal to this is equal to this, and this is equal to this. Under what? SAS, that is, 2 sides must be equal, and one angle must also be what? Equal. This side is equal to this, 2 angles are what? Equal. This is also what? 2 angles must be equal, and one angle and one side with one what? Side equal. That is, angle this and angle this are equal to what? This angle, and the side is what? Equal. Same as this AAS. And in the right angle triangle, in 90-degree triangle, which is a right angle triangle, one side, this is the hypotenuse, equal to the hypotenuse, and one side must also be what? Must be equal. One side must also be what? Equal. So this is how you consider what? A congruent triangle. A congruent what? Triangle. When you say angles are what? Congruent, that is, they have what? The same dimension. So let's go to let's talk about we'll go to the next slide, which is the properties of a parallelogram, and we'll look at the properties of what? Intercept theorem. You don't know what a parallelogram is. A parallelogram, the opposite sides are equal, the opposite sides are parallel. You all know what parallel lines that do not mix. But in this case, the opposite side, all the 2 opposite sides are what? Parallel. The opposite angles are equal, the diagonal bisects one another. Let me show you the diagram of what we just talked about. Properties of parallelogram. That is, opposite sides are what? Equal. That is, AB is equal to what? CD. The side AB is opposite to what? The side CD. So they are what? Equal, indicated what you can say, indicated what? With one slide shows that what? Equal. This AB is equal opposite to what? CD, and they are what? Equal. While BC is opposite to what? AD, and they are also what? Equal. But both are what? Parallel what? Lines. They cannot what? They cannot meet. Opposite sides are what? Parallel, and opposite sides are what? Equal. As said earlier in the properties, opposite sides are equal, opposite sides are what? Parallel. So opposite angles are also what? Equal. Angle A is equals to what? Angle C, while angle B is equals to what? Angle what? D. Opposite angles are also what? Parallel. But when you bisect, when you divide it into two, told you splitting into two, that you have a line, join the line from what? AC and BD. Let us point the point of intersection be what? Label E. That is DE must be equals to what? BE. And AE must be equals to what? CE. That's what it talks about here, that the diagonal bisects one another, and the what? Either sides of the what? Diagonal must be what? Equal to the other side. That is, if you are, this is the diagonal from what? AC and BD, they meet at the point of what? E. So AE must be equals to what? CE, and BE must be equals to what? DE. So it is easy to now follow all those steps like that. So we look at the intercept theorem, which is the last thing we'll be considering today, the intercept theorem. So we all know what intercept means, where it is a word form from what? Intersection, where two lines meet the point of what? Intersection. Let's look at this line. This is a transversal line, and these are parallel lines. So at this point, A here is a what? It's a point of intersection. That is where the parallel line meets this transversal line as a point of intersection. Where B meets this point is also a point of intersection. C is also a point of what? Intersection. So we just look at the brief explanation on the what? On the theorem. When a transversal line cut across two lines, this is a transversal line. Cut across what? Two lines. The part of the transversal line that is enclosed within AB, within the two lines, is referred as what? Intercept. The part of the what? Transversal line that is cut and enclosed within, we're talking about AB within the what? Transversal line, and the what? Parallel line drawn. So AB are within, and also BC are what's within. That is, from this point to this point are the what? Intercept we'll be considering, and BC, that is from this point to this point, A pi, and from here to B pi here, also here from what? B intercept to the C intercept here. So these are what we are talking about here, the intercept theorem we'll be considering. So when a transversal line cuts across two lines, the part of the transversal that is cut and enclosed, this point within the two lines is referred to as what? The intercept. So we look at the properties of what? Intercept theorem. We just consider what? Two theorem in this topic, on this week's topic. We'll look at the two theorem. We consider first the midpoint theorem first. So this is this is a transversal line, and this is a parallel line, MN, and what? BC. A line like AB and what? AC. MN is a what? Parallel line, and also what? BC. MN is parallel to what? BC. So in midpoint, the midpoint below states the properties of line joining the midpoint of two sides of what? A triangle. It's under what? Intercept. You can see the point what? Between these two lines, AM, we're considering AM, and what? BM, also consider what? AN and what? CN. AN and what? CN. So the line segment joining the midpoint of two sides of a triangle, that is AB and AC. The line segment joining the midpoint, that is MN, is the line segment joining the midpoint of two sides of a triangle, is parallel to the third side. This is the third side, what? BC, and is half the length of the what? Third side. That is MN is what? Half of what? BC. MN is what? Half of what? BC. MN is half of what? BC. The line segment joining the midpoint of two sides, that is two sides of a triangle, AB and what? AC, is parallel, that is MN is parallel to what? BC, and is half of the length of what? The third side, that is MN is half of what? BC. MN is half of BC. So this is a triangle ABC. If AM is equal to what? MB, AM is equal to, you can see they are indicated like AM is equal to MB, and AN is also equal to what? NC. MN will be half of what? BC. That's what the first theorem of the what? Midpoint theorem states, of the intercept theorem states. That is, the line segment joining the midpoint of two sides of a triangle is parallel to the third side. Is parallel to the what? Third side, and is half the length of the what? Third side. So if you are given this, we are given a triangle like this, and a midpoint is given. They are given the value of this to be 2. Let's say consider, or given that MN equals to 2. Find BC. It is also it's easy. If MN is 2, then you know that MN is half of what? BC, according to the theorem, that is MN equals to what? 1/2, that is BC. So BC therefore will be equals to what? 4 in that what? In that case. It equals to what? 4 in In that case, that's the intercept theorem. First one we consider. So the second one, if three or more parallel lines, we call this one the transversal line theorem. So if three or more parallel lines, UV, WX, and YZ, UV, WX, and YZ, these are the three parallel lines, cut off equal intercepts on a transversal line. This is what the transversal line, the equal intercept, that is UW equals to what WY, VX equals to what XY. If three or more parallel lines cut off equal intercept on the transversal line, then they cut off equal intercepts. They cut off what? Equal intercept on any other transversal. That is the intercept of this also is equal to what? The intercept cut off what? On another what? Another what? Transversal. If three or more parallel lines, that is UV, WX, and YZ, UV, WX, and YZ are cut off equal intercepts, cut off equal intercept on a transversal. On this what? Transversal, that is this first transversal, UW equals to what? WX. WY rather. UW equals to what? WY. Yeah. And also on the other what? Transversal line again. Yes, sir? The second transversal line, they cut off what? Equal what? Intercept on other transversal. So if you want to calculate this, you can easily say this is a theorem which is UW over what? WY. UW over what? WY is equal to VX over what? XZ. If this is given as, let's say, 2, this is given as 4, this is given as 6, you can easily find what? XZ following what? This theorem. When three or more parallel lines are cut off equal intercepts on the transversal, then they cut off what? Equal intercept on any other interval. So if you are looking at the intercept theorem and you are having a condition like this, you just follow the what? The theorem, which is what? UW, the interior, the within or the intercept of UW over what? WY equals to what? VX over what? XZ. So we've come to the end of the topic. We talked about some of angles in a triangle. Talked about the relationship of triangles on a straight line. We talked about the interior and exterior angle, the angles formed when a transversal line cuts two parallel lines, that is the corresponding angle and the alternate angles. And I told you about we talked about the parallelities of parallelogram and also what? Intercept theorem. I believe you understand all this explanation. You can go back to your notes and read more. I've sent a note earlier and also solve questions in the questions attached to the notes. You get questions attached to the notes on the website. And also, if you want to, for better understanding, you can go to your textbook and also solve further question using all these explanations and formula provided here. Thank you. I will see you in the next class.